So next up is dividing polynomials. But before we learn how to divide polynomials, let's look over how to complete long division. So using long division, let's evaluate 107 divided by 4. So first we look at the hundredths column, and we see we have the number 1, and 4 does not go into 1. So then we go over to the tens column, and we do see that 4 does go into 10, and 4 goes into 10 2 times. So we place the 2 on top. 4 times 2 is 8, so we write 8 below the 10, and then we subtract, and that gives us a 2. Next step, we bring the 7 down, and then we say, how many times does 4 go into 27? Well, 4 goes into 27 6 times, and we know that 4 times 6 equals 24. Subtracting 27 from 24 gives us 3. When using long division, this right here is called the remainder. This is the remainder. This is the remainder of the dividend divided by the divisor. And up here we call this the quotient. So what we have shown, however, is that if we take 107 and divide it by 4, that is equal to 26 plus a remainder of 3 that still needs to be divided by 4. And finally, every division statement can be rewritten as a multiplication and addition statement. For example, 107 is equal to 4 times 26 plus 3, and that's what we have here. So if you take 4 times 26 and add 3, you'll get 107. So now let's look at dividing polynomials. So it's a similar setup. We have x minus 3, which is our divisor, and our dividend is 3x cubed minus 5x squared minus 7x minus 1. So right away we look at the 3x cubed and the 5x squared. Because we have a binomial, we're going to subtract 2 terms at a time. So what do I need to multiply x minus 3 by in order to get a 3x cubed? If I take 3x squared and multiply it by x minus 3, I'm going to get the following expression. I'm going to get 3x cubed, if I expand those brackets, minus 9x squared. And now I subtract. 3x cubed minus 3x cubed equals 0, and negative 5x squared minus negative 9x squared gives me 4x squared. Same as long division, I bring the next term down, so that's the minus 7x. And then I look at the 4x squared. What do I need to multiply x minus 3 by in order to get rid of the 4x squared? So I'm going to multiply x minus 3 by 4x, and that gives me 4x squared minus 12x. So again, I multiplied it by 4x, so I add that to my quotient. Let's subtract one more time. So the 4x squared minus 4x squared equals 0, and the negative 7x minus negative 12x equals 5x. Next is to bring down the minus 1. And what do I need to multiply x minus 3 by to get rid of the 5x? Well, I need to multiply it by 5. And that gives me 5x minus 15. And again, we need to put our 5 in our quotient. And then subtract. So 5x minus 5x is 0, and negative 1 minus 15 is positive 14. So this is the division of 3x cubed minus 5x squared minus 7x minus 1 divided by x minus 3. The quotient, of course, is 3x squared plus 4x plus 5. That's what the question asked for. And one more time, if we were to rewrite this as a multiplication statement, remember it would be the x minus 3 times the 3x squared plus 4x plus 5 plus the remainder should give me 3x cubed minus 5x squared minus 7x minus 1. So how do you check your work? So again, we can check our work by expanding. So using our distributive property, I can multiply the x by the 3 terms in the bracket, and then multiply the negative 3 by those same 3 terms, and then add the 14. So the first 3 terms are 3x cubed plus 4x squared plus 5x. The next 3 terms are negative 9x squared minus 12x minus 15, and then we still have that plus 14. And all we need to do is collect like terms and see what we get. So here's our 3x cubed, that's out. Next, collect our x squareds. So we have minus 5x squareds. Next, go to the x's. We have minus 7x's. And finally, collect all the constants, and we see we have negative 1, which matches the expression we started with. All right, next up, let's determine the remainder of the following quotient. Notice for the x squared plus 1, we're missing the x term. So we're going to include a 0x for our divisor. And as well for the quartic function, we are missing the x squared term. So we're going to add a 0x squared to our dividend. So first of all, we need to get rid of the x to the exponent of 4. So I'm going to multiply the divisor by x squared. And that gives us an x to the 4 plus a 0x cubed plus an x squared. And then we're going to subtract, which leaves us with negative 2x cubed minus x squared. So same as long division, I'm going to bring down the next term, which is 5x. Don't forget to add to your quotient the x squared. Remember from here. To get rid of the negative 2x cubed, I'm going to multiply the divisor by negative 2x. So that gives me negative 2x cubed plus 0x squared minus 2x. Again, if we subtract, we're left with negative x squared plus 7x, and then we need to bring down the 3. Don't forget to add to your quotient. We multiplied by negative 2x, so we had to include that up here. And then finally, we need to get rid of the negative x squared, so we're going to multiply the divisor by negative 1. And that gives us negative x squared plus 0x minus 1. And subtracting, we get 7x minus 4 as our remainder. So don't forget to include our last portion to our quotient, the minus 1. And this is our remainder. So since we're dividing by a quadratic, our remainder can be a linear function. Finally, let's look at why we even bother doing this long division. If you divide a number by another number and the remainder is 0, what can you conclude? So think of it this way. If I take 12 and divide it by 4, we know that the answer gives us 3 and there is no remainder. And what we can say is that 4 is a factor of 12. So in our next example, you're being told that 2x plus 3 is one factor of this function. So that means if I take my function and divide it by 2x plus 3, I should get a remainder of 0 because it is a factor of this expression. So let's see what happens. So let's start by getting rid of the 6x cubed. So I'll need to multiply 2x plus 3 by 3x squared. And when I do that, that gives me 6x cubed plus 9x squared. So subtracting, that gives me negative 4x squared. So I bring down the negative 16x. So to get rid of the negative 4x squared, I'm going to multiply 2x plus 3 by negative 2x. So that gives me negative 4x squared minus 6x. Subtracting these two expressions, I get negative 10x. Finally, we bring down the negative 15. I'm going to multiply the 2x plus 3 by negative 5. And that gives me negative 10x minus 15, which gives me a remainder of 0. So this tells me that 2x plus 3 is a factor of the f of x. That means right now that f of x is equal to 2x plus 3 times 3x squared minus 2x minus 5. So next, let's look at the quadratic. So recall that we can check to see if this is factorable by looking at the discriminant. So b squared minus 4ac. So that's negative 2 squared minus 4 times 3 times negative 5, which gives me 64, which is a square number. 8 squared is 64, which tells us that this quadratic is factorable. So our next line, we have 2x plus 3, and then we need to factor 3x squared minus 2x minus 5. So whatever method you use, decomposition or guess and check, you should end up with 3x minus 5 and x plus 1. So now we can graph this expression. So first of all, we're going to let f of x equal 0. And that tells me that 0 is equal to 2x plus 3, 3x minus 5, and x plus 1. So we solve for each factor. Now note that each factor is of order 1, so it's going to look like a line passing through each of these zeros. The second thing is, recall that our leading term is 6x cubed. So recall that the cube tells us that our end behaviors are opposite, and the positive leading coefficient tells us we go from negative infinity to infinity. So as x goes to negative infinity, we know that y must go to negative infinity. And as x goes to positive infinity, we know that y must go to positive infinity because of the leading coefficient and the degree of this polynomial. So it's going to look something like this with something happening in the middle. So let's sketch that. So our zeros are at negative 1.5, or negative 3 over 2, at negative 1, and at 5 over 3. So again, this is just a sketch, and based upon our end behavior, we're going to go up through the first zero, down through the second, and up through the third. So here's a sketch of our polynomial. Please try the following questions.